In this video, we're going to talk about multiplying expressions that include radicals. Multiplying expressions that contain radicals is very similar to the multiplication of polynomials. We need to first remember this property. So if we take a times the square root of b times c square root of d, the process is I can multiply the two outside numbers, so the a will be multiplied by c, and the two inside numbers under the radical sign will be multiplied together, so b times d. So you multiply what's outside with what's outside, and you multiply what's under the radical with what's under the radical on the other one. Now, once you multiply, then you'll need to see if you can simplify the radical, and do so if you can. Let's take a look at the following sample. We have 3 square root 5 times the square root of 10. So our property says that we are going to multiply the square root 5 times the square root 10, and square root 5 times square root 10 is going to be square root 50. So now we need to simplify the square root 50. To do that, we break up the square root 50 into square root 25 times square root 2, and the square root 25 becomes 5. So we have 5 square root 2. Now, we can't forget the 3 from the very top of the equation. So we're going to bring that down. So it's now going to be 5 square root 2 times 3, or 15 square root 2. Okay, here's two more samples. The top one is simply multiplying the square root 3 through a binomial. So if we go here, again, we're going to take it one at a time. We take this term, square root 3, times the first term, square root 3. So 3 times 3 is 9. So I now have the square root of 9. Minus, now again, we're going to take the square root 3 and multiply it by the whole number 5. So since 5 is not under a radical sign, I cannot multiply the 5 and 3 together. So I simply write 5 times the square root of 3. Now, I notice that the square root of 9 can be simplified. So the square root of 9 is 3, so I've used up the radical sign. So when I simplify this, I have 3 minus 5 square root 3. Since these are not like terms, that means this is going to be my final simplified answer. Now let's take a look at the bottom one. Here I have two binomials. So I'm going to start with the normal FOILing process. I'm going to take the square root of 7 and I'm going to multiply it by the first term in the second parenthesis. Square root 7 times square root 3, that's going to get me square root 21. Then I'll take square root 7 and multiply it by the next term, square root 2. So 2 times 7, that's the square root of 14. Now I go back, continue my FOILing. I now take square root 2 and I'm going to distribute it through the binomial. So square root 2 times square root 3, that's going to give me minus square root 6. And square root 2 minus, or times, negative square root 2 is going to give me minus, that should be plus square root 6, minus square root 4. So if I look in each one of these, I try to determine if I can simplify any of these. Now square root 21, I don't see 4, I don't see 9, so that's going to stay put. Square root 14, well, I don't see 4 or 9, either of those works, that's going to stay square root 14. Square root 6 also can't be simplified. Square root 4, though, can become 2. So since none of these radicals are like terms, in this particular example, I wouldn't combine any together. I would just leave it as this. If I had some I could simplify and combine, then I would do so. Let's try one more sample. So now we have the square root of 10 plus the square root of 5 times the square root of 10 minus the square root of 5. Again, we're going to go ahead and FOIL this together. So over here on the left side, I have square root 10 times square root 10. Square root 10 times square root 10, well, 10 times 10 is 100. Now take the square root 10, multiply it through the second term. So square root 10 times square root 5, it's going to be minus square root 50. Now we take the last term, square root 5, multiply it by the first term of the second parenthesis, and I get plus square root 50. And I finish by taking square root 5 times the last term, square root 5, so plus minus is minus square root 25. Now, square root 50 could be simplified, but I notice that I have minus square root 50 plus square root 50. So either way, they're going to equal 0. So now I'm left with the square root of 100, which I happen to know is 10, the square root of 25, which I happen to know is 5. So in this particular case, it's going to all simplify down to a single answer of 5.